Hello, everyone. Happy Friday. Oh, man, another long one. Hopefully, you guys have an awesome weekend in store. Hopefully, you guys are staying safe. I know at school, just the numbers are kind of exploding, and we just really want you guys to stay safe. So, hopefully, you have fun things to do, just in a safe way. So, here on Friday, we talked about graphing systems yesterday and seeing where they cross. Today I'm going to talk about substitution. We'll probably do substitution for a couple days, make sure we're all good. But substitution is exactly what it sounds like. This marker is sticky because my kids. Okay. Let's see here. So, for example, we had a problem like this yesterday. Y equals 8x minus 1, and y equals negative 3x minus 56. Now, we talked about this a little bit with pros and cons, but negative 56 doesn't sound like a y-intercept that I really want to graph, right? So, substitution is another method I can use to solve these. And basically what substitution says is if you know that what a variable equals. So for in this case, we have y equals 8x minus 1. This stuff is what y equals. And since I know what y equals, substitution says that you can use the second equation, and instead of writing y, we can substitute the stuff that y equals in there for y. So I'm going to take this stuff, I'm going to plug it in for y, and it's going to look like this. 8x minus 1 equals negative 3x minus 56. I'm literally just going to take that stuff that y is, or x is, it could be for x also, and I'm going to substitute it in where I see y or x on the other side, in the other equation, right? And for example, if this told me what x was, I would plug it in for x. But in this case, it's what y is. So I'm going to take that, and I'm going to plug it in for y. And then I'm just going to solve. Now notice now I can actually solve this because all of my variables are x's. I got rid of one set of variables by doing that. That's what's always going to happen with substitution. So now I can add 3x to both sides. Get 11x minus 1 equals negative 56. Add 1 to both sides. 11x equals negative 55. And divide by 11. And x equals negative 5. Can you guys see down that far? Yeah, you're good. All right. So I can do all of that. And I can get what x is. But notice, I still don't actually have my ordered pair where these two lines cross. I also need a y value. So what I'm going to do is now I'm going to take this x equals negative 5, and I'm going to take that and plug it back in for x. So I got y equals 8 times negative 5 minus 1. 8 times negative 5 is negative 40. Minus 1 is negative 41. So the point where these two lines cross is negative 5, negative 41. Now you can imagine trying to graph that. That's an awful long ways down there, which might not be very fun. What's also nice is I think all of my examples turn out pretty, but if they don't turn out pretty, we actually know what the answer is, right? If we graph it and they don't turn out pretty, we have to estimate. We have no idea where it's actually at. When I substitute, I do know where it's actually at. I'm going to get an exact number. So I like substitution a lot. This is probably my favorite way to solve systems. Just, because it's actually fun. And then it's very accurate. So I like that too. All right. I got a couple more for you. Talk about them. Let's go with 4x plus 9y equals negative 7, and x equals 6y plus 22. All right, so here, again, in order to substitute, I need a variable that equals exactly some other stuff. Well, we can use this x because it's by itself, and x equals this stuff, 6y plus 22. So I'm going to take that stuff, the x's, and instead of writing x up here on the top, I'm going to write this stuff instead. I'm going to substitute this in for x. So I'm going to go 4, but instead of x, I'm going to write 6y plus 22. And then keep going, plus 9y equals negative 7. There's my substitution step. Took what x equals, plugged it in where I saw x in the other one. Now we just have some math, right? 4 times 6y is 24y. 4 times 22 is 88. Plus 9y equals negative 7. Add my like terms, 24y and 9y is 33y. Plus 88 equals negative 7. I thought these all turned out nice, but now I'm not so sure. Minus 88 from both sides. That's going to give me 30. Yeah, we're good. 33y equals negative 95. Well, there's no way that turns out pretty, so unless I did something wrong. That's pretty late, so who knows. Let's see. I don't know if negative 95 over 33, I don't think that simplifies at all. All right, so divide by 33. We're just going to leave it as a fraction. Cool. And now again, that's only what y equals. So
did you copy it down now?
Oh, yeah, I don't know. So that's only what y equals. 4 times 24y, 88. Yeah, all right. So let's plug it back in for x. Or I'm sorry, for y. So
It's gonna be ugly.
yeah, let's use this one. X equals 6 times negative 95 33rds plus 22. And then we'll just go ahead and solve. Let's see. 6 times negative 95 is going to be negative 570 over 33. And let's see, I don't think that's going to simplify either. Oh, it did. So that's going to simplify to negative 190 over 11 plus 22. And when I add 22 to that, 22 would be 220 elevenths. That's going to give me the x value of 52 elevenths. Yikes. So that point where these two lines cross is 52 elevenths and negative 95 33rds. Wow. So I thought they were going to turn out nice. Obviously, that one did not. But that's a really good example of why that's going to work. And graphing, obviously, this would be a really, really poor choice to graph those ones. All right. So, all right. I got one more for you. We'll talk about that one. And then you're good to go. Hopefully I didn't screw this one up when I was writing it down. All right, we got 4x plus y equals 15. And I got 13x minus 2y equals 12. Now you notice this one doesn't have any variable equal anything. That's true, it doesn't. So if I wanted to substitute, I'm going to have to rewrite one of them to get either x equals or y equals. And this is going to get to the point where we might think like, oh, maybe this one doesn't, maybe I wouldn't use substitution now. But typically, if it's pretty easy to solve for one of them, I would just use substitution. Like if you look at the top here, it's going to be really easy for us to get y by itself. I can just subtract 4x from both sides. And I can get y equals 15 minus 4x. And now that's completely ready to substitute in for y. So when we talk about elimination next week, question mark? Not next week. When we come back from Thanksgiving, when we talk about elimination, you're going to see like, okay, maybe I would eliminate now instead of substitute. You'll see kind of the pros and cons. But we're going to take this stuff that y is, and we're going to make sure we plug it in for y down here. So 13x minus 2, and instead of y, we're going to put in 15 minus 4x equals 12. Very nice. And now we just go ahead and solve, right? Negative 2 times 15 is negative 30. Negative 2 times negative 4x is positive 8x. Like terms, 8x and 13x is 21x. And then add 30 to both sides. 21x equals 42. And divide by 21. I just realized I wrote kind of small here, so hopefully you guys can see that. But I got x equals 2. So I solved, got down here, x equals 2. Awesome. But I'm not done yet, because I'm looking for the whole ordered pair. So I'm going to take x equals 2, and I'm going to put it in right here. Whoop, all the way in for x. So I got 4 times 2 plus y equals 15. Ooh, this is a really good time for me to say this. Remember, we changed it over here. We rewrote it. When I plug back in, I always plug into an original equation, not one that I messed with, just in case I did something wrong. 4 times 2 is 8. And then just subtract 8 from both sides. And y is 7. So the point where these two lines cross is going to be 2, 7. And there you go. That's how substitution works when you're solving systems of equations. I hope you guys have a great weekend. We'll do more practice on this Monday, and then we'll coast right into Thanksgiving break here. All right? I'm thankful for you guys. I hope you're thankful for math. See you guys later.